Hello everyone, welcome to my presentation. My name is Osama Abdurrahman, a master student in the civil engineering department at Concordia University. First of all, I would like to thank co-author of this project, Dr. Ahmed Sulaiman, for his support. My presentation is going to discuss the properties of sustainable self-compacting mortar incorporating limestone filler. The outline of this presentation: first, we're gonna introduce our topic and literature review, and then we're gonna discuss our objective and result and our conclusion. So, as we all know, cement production has a significant environmental impact, as it's responsible for 9% of the worldwide CO2 emission. Actually, this is due to the fact that 1 ton of cement produce approximately 900 kilogram of carbon dioxide. Global cement production was estimated to be 4.2 billion ton in 2014 due to the fact that concrete is the second consumed material on Earth after water. Moreover, the global demand for cement is increasing. Action has been taken to reach other approaches that could reduce cement consumption, and also government have begun to place a carbon tax on the production of CO2. Such laws, as we know, were implemented here in Canada. The negative environmental impact of cement can be reduced by improving the manufacturing technique, using alternative fuel or clinker substitution. Actually, it has been reported that improved manufacture technique or the use of alternative fuel has less potential in reduction CO2 emissions compared to cement substitution. This is because the main source of CO2 emission in cement production is the clarification of raw material, which produce approximately 50 to 55% of the CO2 emission, while burning fuel produce 35% and transportation produce around 10%. Cement substitution is reported to be the most efficient way to achieve a significant reduction of CO2 emission. This substitution can be done using first of all the supplementary cementitious material, or using a filler as limestone filler. So we are going to use in our research the limestone filler. Limestone filler affect the hydration in 4 main ways. The first, it is far less reactive than cement, so we have the dilution effect. However, on the flip side, we can increase the particle packing depending on the size of limestone particles. And also, if we use fine limestone powder, we can get nucleation. Also, there is some research that limestone is chemically react with the calcium aluminate hydrate and monosulfate to form a calcium monocarboaluminate. And we will see later in the presentation how these 4 aspects come into play. So basically, the objective of this research, I was looking to optimize the limestone content in the self-compacted mortar by taking some cement away to make it more sustainable, and also investigate the influence of limestone content on the fresh and hardened properties, and the hydration kinetics of the self-compacted mortar. Limestone filler with a particle size 3 micron were used as a partial replacement of cement to make it more sustainable, with a percentage 5, 10, and up to 15%. So, for our result, first I examined the flowability of the self-compacted mortar. As you can see here in the graph, all the self-compacted mortar flow in the recommended range between 250 and 300 millimeter. Besides, they maintain a flow time in the recommended range between 2 and 10 seconds. The flowability was enhanced by increasing the percentage of limestone. After that, we examined the heat of hydration. Increasing the limestone content influence the hydration kinetics, as we can see here in this curve. Increasing the limestone content shifts the peak to the left and increase the hydration peak by 15% for 15% replacement mixture compared to the control mix. And finally, for the compressive strength result, if you looked at the early age compressive strength, what was interesting that when the percentage of limestone increased up to 10%, the compressive strength improved by 13%. However, this improvement in compressive strength was vanished after 28 days. So, to conclude, using limestone up to 15% replacement of cement is viable, and using limestone filler, it enhanced the flowability of the self-compacted mortar and the early age of hydration and the mechanical properties. However, the improvement in the mechanical properties was vanished after 28 days. Thank you everyone for listening, and we'll be happy to answer any question.